So some questions, biostatistics. Which one of the question is not correct? Approximately 68.27 of the new data value falls within one standard deviation of the mean. Approximately 95% of the data values fall within two standard deviations of the mean. Approximately 99% of the data values fall within the standard deviation of the mean. Okay, approximately 99.99% of the values fall within three standard deviations of the mean, none of the above. So if you've seen that this is correct, uh, the answer is none of the above, because earlier we said when you have got a normal Gaussian curve like that, here is our mean. If you move one step away to the left and to the right, so what we are using is the empirical rule here. And then again, another step here, another step here, and then the last one here and here. So this is the first standard deviation. So going this direction, that is mu, or the mean, plus one standard deviation. Going this side, it's mean minus one standard deviation. So we call this region as the first standard deviation. And the percentage there is supposed to be 68. Two standard deviations is from here up to there, that is a 95. And then three standard deviations from here up to here, that's a 99%. Okay, so meaning none of this is correct. Okay, we wanted what is incorrect, so none of them is incorrect, so none of them is correct. What should be the median age for the children observed in question 11? Why did I swap these questions? Okay, let me see how they put the question. I think I had swapped the questions. Okay, question 11 is asking about a researcher. I think I had put it down. So this was supposed to be question 11. A researcher from the PID clinic you observe. As a researcher from the PID clinic, you observe the following ages: 8, 10, 8, 11, 10, 8, 9. What would you advise the in charge to be the average? Okay, what to be the average here? Remember, average is the same as mean. Given by how many the terms are: 8 plus 11 plus 10 plus 8 plus 9, and then you divide by how many they are. These are 1, 2, 3, 4, 5. So if you do that, you are going to get 9.2. And then that is where now this question came from. What should be the median age for the children observed above? Remember the terms that we had which ones we are repeating? 8 and 8 is repeating, so it's from 8 to 11, but 8 is repeating. So arrange them in ascending order. So 8, 8, 9, 10, and 11. So the median is the number that is falling on the middle. You can see that is a 9. The values below represent ages for another set of adolescents and young people that participate in a study. Using the ages recorded below, what is the variance associated with the group 9, 12, 15, 15, 15, 16, 16, 20, 26? Now, for you to find the variance, the first thing that you have to calculate is the mean. So let's find the mean. The way you find the mean is you add these terms: 9 plus 12 plus 15 plus 15 plus another 15 plus 16 plus 16, and then plus 20 plus 26. You divide by how many there are. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me do that. So 9 plus 12 plus 15 plus 15 plus 15 plus 16 plus 16 plus 20, and then plus 26. That's a 144. Divide that by a 9. So that is going to give us a 16. Now for us to find the variance C, the first thing that we need to find is we should be subtracting x minus the mean. Okay, we'll be subtracting x minus the mean. So we'll get the first value, we remove the mean. The first value is 9. So 9, actually I'm going to be doing this. I get the value, I remove the mean, and then I square. Okay, I get the value, I remove the mean, and then I square. So for the first one is 9, the mean is 16. So 9 minus 16 is a negative 7. Square that, it will give you a 49. Go to the next one, which is a 12. 12 minus 16 is a negative 4. Square that, that's a 16. The next one is a 15. 15 minus 16 is a 1. Square that, that's a 1. The next one is also a 1. The next one is also a 1. The next is 16. 16 minus 16, that's 0. And then the other one is a 0. The next is a 20. 20 minus 16 is a 4. 4 squared is a 16. The next is 26. 26 minus 16 is a 10. 10 squared is a 100. The next one now that I need to find is the sum. So it is the sum of x minus mean squared. In other words, just add the numbers that are on top there. Okay, so 49 plus 16 plus 1 plus 1 plus 1, then plus 16 plus 100. So that is going to give us 184. Remember this one, no? The value below represents ages for another set of adolescents and young people that participated in a study. The thing is that you can't pick everyone that is available to participate in the study, meaning that this is actually just a sample. And for a sample, the variance given by s squared is given by just the summation of x minus mean squared divided by is always n minus 1. So we've already calculated the summation, that is 184 divided by n minus 1. So that is the total number of terms were 9. So that is 9 minus 1, which is 184 over 8. And that is going to give us a 23. So that's why for this one, I just put no correct option because there was no answer here. Hope that's okay. The next one is saying, imagine you have a jar of 12 unique glass beads. If you are sampling without replacement from the jar, the chance of randomly selecting any one of the glass beads is 1 out of 12. What is the probability of selecting a second bead? Remember, we have got 12 beads. Okay, you are sampling without replacement, so don't put back. So since you have got 12 of them, if you sample the first one, you remove one. The chance, of course, of sampling is 1 out of 12. But the probability of selecting a second one will be now out of 11 because you've removed one at the beginning. So it will now be 1 out of 11. Okay, because the total has now dropped. And then the next, sampling without replacement can be defined as random sampling that does not allow sampling units to occur more than once. Okay, so that's known as a jackknife procedure, where you random sampling, where you sample and then you don't allow sampling units to occur more than once. That's what it is known. That's the name, jackknife procedure. Imagine you have a jar of 12 unique. So if you have got, say here is our cup that contains beads there, okay, and then you remove a sample from there, a random sample, but you don't want to pick that same thing again. So you've just picked it, you don't want to pick it again, meaning you not put it back, isn't it? So we call that a jackknife procedure. If you pick one, you sample one object, That's done. You will not sample it again. Okay. Is that okay? Imagine you have a jar of 12 unique glass beads. If you are sampling with replacement from the jar, the chance of randomly selecting any one of the glass beads is. So remember, this one is you are sampling with replacement. So you had 12. You sample for the first time, but then you replace it. So if you sample for the second time, it will still be 1 out of 12 because you have replaced the previous one. In statistics, use of bootstrapping is a statistical procedure that uses sampling with replacement on a dataset to create many simulated samples. So this one is just a statement again. Statistical procedure that uses sampling with replacement on a database to create many simulated samples. Okay. So you get a sample, and then they've already defined the terms here. Sample with replacement. So I think they were supposed to put a dash there, and then I forgot to put a dash. So that is sampling with replacement. Subdivide the population into at least two different subgroups that share the same characteristics. Then draw a sample from each subgroup or stratum. What do you call this type of sampling? Multi-stage, cluster, purposeful. So the answer is none. So what was supposed to be the answer here? If the correct answer was supposed to be there, since there is no answer, what was supposed to be the answer? Okay, it was supposed to be stratified, isn't it? Members from the population are selected in such a way that each individual member in the population has an equal chance of being selected. What do you call such a type? So that is a now it's a random sampling, but to be specific, it is simple random sampling. And then you have got the figure below represents distribution of babies. So distributions are shown. What would you deduce about the distribution shown? You can see here is the median or the middle, and then you have got one outlier on top, and then you have got again an outlier going down. So I've got what we call the measures of dispersion. Here we have got the quartiles or quartiles. So what you do is if you have got the middle value, you can add a 25% going in those percentages 25, 70, 50, 75 going forward. But the easy thing here is that you can see going forward, we have added 1 over 5 times QR. Going beyond, we have removed 1 over 5 times QR. So this distribution is a normal distribution. It is not skewed. You can see what is forward and what's behind is the same. The subtraction behind and the addition forward is the same. So that is a normal distribution curve. Selecting members from a population in such a way that each member of the population has a known but not necessarily the same chance of being selected is probability sample, convenience sample, purposive sample. So in probability sampling, remember the two main types of sampling. I've got probability sampling and non-probability sampling. In probability, each member of the population has a known chance of being selected. But they don't have the same because one guy, the chance of picking the guy can be 2 out of 5. The other one can be 1 out of 5. You know it, but it will not. But it's not the same probability. Okay. The one where you have got equal chance of being selected is simple random sampling. You have been a student in the School of Medicine, and one of the concepts required for one to be grounded in research is the knowledge of biostatistics. Which of the following is correct about biostatistics in general? It's a science of planning, studies, and experiments, obtaining data and organizing, summarizing, presenting, analyzing, interpreting, and drawing conclusions based on the data. It uses mathematical techniques, sometimes simple, sometimes more complex, to summarize data in a way that can be used to answer, or at least attempt to answer, a scientific question of interest about business and environment. It is a study of human and their associated numerical conditions, none of the above. So you can see we did say this is the definition, isn't it? Even B was supposed to be correct, except the last part makes it wrong. Of course, biostatistics uses mathematical techniques, simple or complex, to summarize data in a way that can be used to answer, or at least attempt to answer, a scientific question of interest. But if you say about business and the environment, then it's not general, because that one is not specific. Okay, we wanted the general definition. That's why B is not correct. The process of using data obtained from a sample to make estimates and test hypotheses about the characteristic of a population is known as hypothesis testing, statistical inference, sampling. So remember we said that statistics can be divided into two main ones: descriptive statistics and then inferential statistics. Descriptive statistics answers a descriptive question, inferential answers a question of estimation and hypothesis testing. And here we've been told makes estimates and test hypothesis, so that is inferential statistics. Population is for census. Sample survey is for they should have just said survey is for, so that is a sample, isn't it? So population is census, and then survey is for a sample. Same, just like what other terms? Parameter and statistics. Parameter is for a population. Statistics is for a sample. The strength of the median is that it is not sensitive to outliers. True? Correct? Not correct? I don't know. None of the above. You can see how simple this is, isn't it? We've discussed everything here. So the median is not sensitive to outliers. So since the median is not sensitive to outliers, what is sensitive to outliers? Anyone who can answer that? Excellent. The mean. All right. A, stati- a statistician uses mathematical techniques, sometimes simple, sometimes more complex, to summarize data in a way that can be used to answer, or at least attempt to answer, scientific question of interest. True, the statement is correct. False, the statement is wrong. I don't know. None of the above. Okay, we know that's true, right? We've discussed that. We answered it again. When the data is normally distributed, which statement is correct? For symmetrical data distribution, mean is equal to median, which is equal to mode. For positively skewed distribution, mode is less than median, which is less than. Let me show you this again. For the normal distribution is like this. Okay. So the top part here is going to be mean is equal to mode, which is equal to median. And then we have got data that is skewed to the right side. And it looks like this. For the data that is skewed to the right side, this is going to be the mode. The median first is going to be on the middle. So the median will be somewhere here. And then when you find the mean, remember the mean is sensitive to outliers. So the mean will end up being pushed even a bit further. So the mean might be here. So this one that is shifted to the right, like this, we call it negative. Okay? Negative skewed data, or negative skewed. Because skewed, you are looking at this camera line, it is more longer on the left side. And then for the positive skewed is the one that will go something like this, and then it goes like that. So it's going to be opposite. This is going to be the mode. The median is going to be somewhere here, and then the mean will be a bit far. So you can see how they are. For this one is positively skewed, also correct. Looking at the graph. By showing your working, please prove that the population variance is the unbiased and sufficient estimate of the sample variance. So I'll ask you to do this one. And then you have this. Assume there is a population of size n is equal to 4. You pick a random variable x, representing the age of individuals in the population. The age value of x are shown as below. You have got 18, 20, 22, and 24. The first part of the question is, using the ages given above, what is the population mean and standard deviation? So you can calculate that, isn't it? What do we call the computed mean and the standard deviation? So that will be the sample mean and sample standard deviation. Compute the proportion of selecting any one of the indicated guys. So each one of them is going to be 1 out of 4 because each age is only appearing once. And then plot the figure. We even did plot the figure. So the figure is going to be something like this. They have got all the same proportion of 0.1 out of 4. What percentage is that? 0.25. Now consider picking all possible samples of size n. Indicate by way of showing your working the number of samples you would pick. So the number of samples we're going to pick, because we have got 4 samples, but we want to pick with a sample size of 2, so it will be 4 combination 2, that will give us 6. So you make all the possible combinations, there should be 6. If you start with a 2, you also have a 2, 2 and a 3, and then 2 and a 4. If you go to 3, you can't have 3 and a 2 because already there. 3 and a 3, 3 and a 4. If you go to 4, you can't have 4 and a 2 because it's already here. 4 and a 3 is already here, so you just have 4 and a 5. So you can see these guys are 5. Okay. As you pick the samples, make sure you compute the sample means and show your working. So find the mean for these two, the means for these two, the means for those, the mean for this, the mean for this, the mean for these two. So just add 2 plus 2, divide by 2, just like that. Draw the sampling distribution of the means. So if you find the sample means, the graph you should find should be something like that. Okay. And then compute the standard deviation of the sample means. Let me just show you how the graph is appearing. So this is how the graph will come out, because when you calculate the means, you are going to find that the means, you have got 19, 20, 21, 21, 22, 23. And then you can now just come here. The only thing that is high, that is appearing twice than everyone else, is 21. So this graph is still following the normal Gaussian distribution. Okay. And then compare the figures that have been plotted, the first one that we plotted and the second one that we plotted. Compute the standard deviation of the sample means. So the standard deviation of the sample means, remember you found the means. Now I want to find the standard deviation of the mean. So the way you do that is that you just first find the standard deviations. But you already calculated the standard deviation of the sample at the beginning. Remember the first question. And then just get that you divide by n, which are the means. The means are just 2, 2, 2, 2, 2. So that will give you a 1.5. And what do you call the computed quantity? So this standard deviation of the means, we call it the standard error of the mean. Standard deviation tells you just how many steps away you are moving from the mean. So it's a standard error of the mean. Write in symbols the correct formula for generalizing it. So if you want to find the standard error of the mean, you can just say standard deviation divided by the square root of n, n where is the number of terms that we are dealing with. So basically that is that.